So hi everyone to another of the container service webinars. Today we have Clemens Lang from CERN and the CMS experiment presenting us presenting to us and talking about analysis workflows and how he uses Argo CD for this purpose. So as usual, if you have any question, feel free to write something in the chat or in the Q&A box, and then we'll handle it at the end. And I pass to Clemens. Thanks, Clemens.
Thank you, Ricardo. And yeah, thanks everyone for joining. So the title of my presentation is From Zero to Running Physics Analysis Workflows with Argo CD. And this talk is mainly about doing GitOps using the CERN OpenStack Kubernetes clusters. And here with a focus on like how one could use it, for instance, to get a physics analysis workflow to run. The main motivation for this presentation is that Kubernetes and also the apps that are deployed onto Kubernetes are continuously evolving, and it's somewhat challenging to stay up to date. And off-the-shelf apps often need to be customized. I mean, you probably all remember that whenever you go and find a new product or a new Kubernetes app, the first thing they tell you kubectl apply -f this and that, and then you apply something to a cluster, and maybe it works out of the box, maybe it doesn't, but you know, you've done something that is not observable in an easy way. And I actually want to have an easy way of keeping track of all the changes and what is happening inside the cluster that I'm using. And GitOps seems to be the best way of doing this. I should note that Argo CD, so Argo Continuous Deployment, is similar to Flux, and there's been a recent tutorial by Ricardo on this about 3 months ago, and you'll see some similarities. But this presentation really focuses here more on the GitOps aspects than rather than managing physics analysis at large scale. And it's actually not something where I'm going to be talking to you all the time, but I created a repository that I'll be using. I'll be switching this back and forth between slides, the terminal, and this repository. So you're very welcome to use this repository and actually follow along. I hope I'm not going to be too fast. Okay, so now the only thing you actually need in order to be able to follow this is a shiny new cluster. So I just added here the command that I ran about 2 or 3 hours ago. So I created a new cluster with the latest, greatest cluster template, Kubernetes 1.18.6. Asked for 3 nodes, and I wanted to have a larger node, so I asked for M2 large. Okay, and then what you usually do if you follow the Cloud Docs quick start instructions that are linked from the bottom here, you get the config, pipe that into an environment file that you then source, and well, there you have it, your new and shiny Kubernetes cluster. And the question is, what do you do next? Okay, I mentioned it at the beginning. Usually you would probably run a lot of kubectl apply -f or helm install this and that. And maybe you have a repository that contains all the manifests. So you would first clone this repository and then kubectl or helm install all the way. But the issue is still, how do you actually observe what's installed into your cluster? And how do you upgrade and roll back if things go wrong? And do you want to do this all the time when you actually create a new cluster and want to migrate Kubernetes versions and things like that? Okay, I think Argo CD, just as Flux, is a great solution to say reduce the number of kubectl commands that have to be executed. And the following will be using Argo CD. With a focus on using it in combination with Customize. I'm going to talk about what this is a little later. And I just wanted to point out that Argo CD actually supports a wide range of tools with which Kubernetes manifests can be defined. So there's Customize, and I personally like it. Of course, so there are also Helm charts that are provided. So you could probably rerun the example that Ricardo had in the Flux tutorial. Also supports case sonnet applications, and also simply, for instance, a directory of YAML JSON, JSONet manifests, including JSON itself. And in principle, even any custom config management tool configured as a config management plugin can be used. And these are all, the underlined words here are all links to the documentation for Argo CD. Okay, so I said I wanted to reduce the number of kubectl commands that I will have to run, and I'm actually going to run these 3 commands. That's all I'm going to do, and then I'll probably run another kubectl forward a little later. But that's all the kubectl or Helm install that I will run. And this is following the Argo projects, so Argo CD getting started. And everything else will be done using Argo CD, either using the web interface or using the command line client. And again, you're very welcome to follow the tutorial there, and I'll actually be copying most commands from there. So I'm going to switch over to this repository. Should be world readable, so you can use it. It lists here a couple of prerequisites of what is needed in order to start running. So you need a cluster, and you need to have kubectl. So for instance, you could work on LX Plus Cloud, see installation instructions for kubectl here in case you don't have it installed on your machine. And I personally also recommend you have a virtual machine under your control there, because we'll be doing some port forwarding of Kubernetes services. And if you do that on a publicly accessible machine, also everyone else could in principle connect to these services. Okay, and if you want to change things as we go along, it's probably good to fork this repository and or even create your own from scratch and just copy whatever you think is useful from there. Okay, so the first thing we'll do is to install Argo CD. So that means we will have to create a namespace Argo CD and then directly apply a manifest from the Argo CD GitHub repository. Okay, so first I want to show you that I'm not cheating. So I have a terminal set up here. So I'm here on my local machine, and you can see that I currently do not have an Argo CD namespace installed. And also if I look at the nodes, you can see they've been created a bit more than 2 hours ago. So this is my shiny new cluster, and there's nothing running in there. So now I'm gonna run the commands that are listed here. So I'm gonna create this namespace Argo CD, and then I'm gonna apply this manifest to get Argo installed in the first place. So this is actually installing quite a lot, but I've done it before. So this should work, and we should be up and running in a minute or so. So of course, it installs a lot of custom resource definitions, then service accounts, RBAC roles, cluster roles, role bindings, and also config map secrets, and then lots of services and deployments at the end. Okay, so now we have this installed, and while all the images are being pulled and the pods are being started, we can actually install the Argo CD CLI. So the command line interface. So I here just put the commands that are required in order to install this on a Linux machine. You can also brew and install it on a Mac. The instructions linked here. So I already have the Argo CD CLI installed, and you can see at the moment I do not have a connection to my cluster. So that's the next thing that I will have to do. So if you're running this, you can just execute these commands if you're on Linux. Otherwise, you will have to change the command here, so it won't be Linux AMD 64, and that should get you the CLI, which is a Go binary. Okay. Now on a machine under your control. So for instance, an OpenStack VM, I have a CC7 one defined. I would now actually forward this Argo CD server service. You can see here that it has been created. And I will now go to the machine here that I have. I've already sourced the environment. Now I'm going to forward this port. Okay, So this is doing something. Now, since I'm currently not inside the CERN network, this is all I have to do, and I do not have to, for instance, set up a firewall. You can see, open firewall ports in the firewall, but I can directly run, and I have an SSH tunnel to this machine so that I can access it on my local host. Okay, so now this should already work. So now the Argo CD server service or installation is protected by a default by a password, which is generated from the pod name, and we can extract that by running the following command that I just pasted. So I actually cheated. There's another kubectl command that we need to run, and you can see now this is the Argo CD server 659. It'll be different if you run it yourself, but we can use that in order to log in to our server. Okay, since I said I'm forwarding things here, I can actually, so I'm forwarding the port to port 4000, so I can actually log in like this. Okay, I will get a warning because I haven't set up any SSH or SSL certificates. So I will just proceed insecurely and accept that here. Now it's asking me for my username. It's admin by default. I'm just going to copy this command here and then paste the password. Okay, and now I'm logged in. So first thing you should do is actually change the password. So I'm going to do that. And that's going to ask me again for the current password. I'm going to paste this, and then I'm going to set a new password. Okay, and that's it. So in principle, we have everything running, and so we connected to Argo CD via the CLI, but we can also do the same thing using the using our browser. So for me, again, it's running on 4000. It'll be different for you depending on how you forward or how you access your machine. Okay, and now I'm here. I'll put in the admin username. I'll put in the password that I've just set, and here we are. So there are no applications yet. So Argo does not even know about itself at this point, but we have something installed. Okay, now the next step that we're going to do is actually to manage Argo CD with Argo CD. Okay, so this is now moving on to the next part of this tutorial. I've directly linked it from the bottom of the main README, and you can see what needs to be done. Okay, so Argo CD allows one to create apps, and we can actually create an app directly from this repository that we are looking at. So within this tutorial is contained. We will point it to a path, and we will look at what is inside this path in a minute. And then we set also a destination server. So that's just a hint that actually we're going to use the default Kubernetes service here, which means we're going to install Argo CD into the cluster into which Argo is already installed. In principle, we could also install this into different clusters, but that's not something I'm going to show today. And we're going to set a destination namespace, which is Argo CD. So in principle, we're replacing what we installed via kubectl. Okay, so this points to a directory Argo CD in this repository. And you can have a look. There's only one file in there, and all it does, this is the API version, then a customization, and it points to a resource. And it actually, again, points to a resource inside the Argo CD GitHub area. And if you browse this, you would actually see that, again, in this directory cluster install, there is a customization file that then points to other files, and in the end points to some manifest that installs all the services. Okay, and here one thing to note, I'm actually not using, let's say, the head of this repository, but I'm defining that I want to use a tag. So in this case, it's stable, and it would work similarly if one wanted to use a certain branch. Okay, so in principle, we're not customizing anything. We're just using the customization to directly install what we get from, say, the upstream repository. And in terms of this URL formatting, so why you actually put this question mark and then the ref and the branch or tag name, this is following the HashiCorp go-getter URL format. Okay, I've replaced. I've explained everything else, so now let's actually run this command and see what happens. So this actually will take a couple of seconds, because before doing anything, Argo CD will actually download the repository and make sure that all the manifests are valid and there are no bugs. So you actually, if you have a typo in your manifest, which means that there's something invalid in general, or doesn't even, it's not valid YAML or anything, it'll already fail at this point. This worked fine. And now if I switch back to the UI, I can actually see that I have now the Argo CD application here. It's shown as healthy because we already installed it, but it's shown also to be out of sync. So it points to this path installed into the default cluster and into the namespace Argo CD. So now, in order to be able to observe this, or what's going to happen now. So basically, I haven't changed anything. I still have the kubectl applied configuration, but you can now see what actually came with this install command. You can also see what is green, so what is already deployed, and you can see things that are out of sync and therefore will have to be created. Now, you can look at the diff. And this will be a huge diff, so we won't be looking at it very long. But you can see for each file what is the diff between the manifest that is already installed into the cluster and the one that will come. So for instance, here, there's just a label that is added to lots of the manifests. You can actually also then directly see the manifest themselves. So this is actually what is created from this command line, from this command that I created. And you can also see which images are running. So there's Argo CD version 1.7.6, and then there's Dex and Redis. Okay, and I could also enable autosync. That's something we're going to do later on. So for now, all we're going to do is we're going to click on sync, and we're going to see what's going to happen. And what is out of sync, and then I could also selectively sync what I want to sync, but now I just want to synchronize everything. And now you will see how all this updates over time. And in principle, if you went back to the tutorial, I could also have done this via the CLI. But then actually have it listed here. So it's the Argo CD app sync Argo CD, and now that means once this is done, so it's already healthy, synced, and okay, so it's already done. Now I have my Argo CD installation under full control. Under, it's already doing GitOps basically here. Okay, so now that's the first thing to be done. Now we want to do something useful, because I said I want to run a physics analysis workflow at some point. So in order to do that, we're going to install another Argo or another product of the Argo family, which is called Argo Workflows, or short, simply Argo. So it has in principle nothing to do with Argo CD. They just happen, but of course they're part of the same, let's say, GitHub organization. Okay, so we're going to do something very similar as we've done for the Argo CD installation. Again, we have a directory. I called it 02 Argo Workflows, which again only contains a customized file like this, and that now points to Argo and not Argo CD. So now let me execute this command. So it's in principle the same thing. The difference here is again that I'm actually now installing into a namespace Argo, so not Argo CD. So this will do something. And if I now check again what's happening here, you will see, oh, there it is. Now there's Argo Workflows, okay? And at the moment, it doesn't have any status. Okay, now this has been updated. We've found that we are actually out of sync and there are no health checks because there's nothing installed. Okay, so back to the tutorial. So now I can, okay, I should mention one more thing. I actually added one parameter here to the end, which is a sync option, create namespace equals true. So if I had not added this, syncing the app would have failed because the namespace would not have been created. That wasn't a problem for Argo CD because the namespace already created. It was already created. I created it myself at the very beginning, but now this isn't the case. So now, which is why I had to provide this additional parameter. Okay. I'm doing this via the command line. There's a lot of stuff happening. Well, you can see the status is progressing. And again, I can see and check what's going on. So I can actually also see now, what is the latest commit that I'm using. So there's one from 3 hours ago, and I had a commit to that with a comment that is I'm reverting to something stable. And so this is perfectly in sync. And again, I can observe exactly what is installed into my cluster. And similar to the dashboard, I can also filter if I wanted to and display things in a different way or a simplified way. Yeah, so that's something for everyone to play around with. Okay, so now we have Argo Workflows installed. Now we have to run a first workflow. Okay, so again, Argo Workflows, it comes with a command line interface that makes it easier to submit these workflows. I've again put here the commands to get the latest, greatest Argo workflow in version or CLI version installed. So that's for Linux. Oh, actually, I made a, I think there's a typo here. It should be tar. Okay, you'll figure that out. You unpack it, and then you have Argo installed. And I can actually also just run Argo version. I have it installed already. You can see I have also the latest, greatest version from a couple of days ago. Okay, so now let's try to run a workflow. So this is the hello world workflow, again, taking the manifest directly from the repository. So now let's see what's going to happen. Whoops, sorry. Can make this a bit bigger. So at the moment, everything's still fine. I'm running the workflow. It's, I have a pod running here now. It's container creating. So that means it's pulling the image, and the first time that always takes some time. Oh, and now it's done. But actually the status here is error. And I get a message, failed to save outputs, failed to establish pod watch, timed out, waiting for the condition. Okay, and that's an error message. Now you can use a web search to figure out what's going on, or use the Cloud Containers MetaMouse channel and ask, like, has anyone seen this before? And then Spiros, Thomas, or Ricardo, or someone else might say, oh yeah, I know this error. And that's actually something wrong. You're missing something in your installation. So the default installation didn't work. Okay, so now we actually have a reason to look into a customization. So that's moving on to part 3. That's again linked from the slides here. Okay, so now what we can actually do, so far we've only had a remote resource that we pointed to. Now we know that we actually have to install some RBACs and say these RBACs, they're not too interesting. You can look at them. It basically defines a new service account, Argo workflow service account, and then also a role and a role binding. Okay, so this is perfectly fine. We could directly put this into to our code. So I've actually created a new directory here. So it's called 03 customization. So in this customization file now, I have the standard installation, and I create an additional resource, which are these RBAC roles. So they have in principle nothing to do with the default installation. So I can just add, so they're independent of the main installation. So I can just add them as a resource. Now, another thing that one has to do in order to get workflows to work is increase, is actually use this workflow that we, the service account that we just created, and also add a security context in order for these images or these containers to work. So I have to patch the default config map that comes with the Argo Workflows installation and add something on top. So I actually just create this workflow map, but I only define the fields following down the tree that I want to change, and everything else I keep the same. And that's what is then referred to as an overlay. And it's not a resource that I will then create, but I will actually create a so-called strategic merge patch. And you can look into the documentation for customize what this means. There are also different kinds of patches, but this is good enough. And you can actually see that in my repository here, I now have a new directory, or actually two new directories. So I have a base directory where I installed let's say the base resources, so my workflow RBAC here, and also I have an additional directory which I call the overlays, and in there a production directory within which I actually put this patch file. Okay, and the reason why I use this additional subdirectory production is that it could be that I wanted to have different patches on top of a base installation, and I want them to be different for different clusters. So run one as a, let's say, staging or test cluster or dev cluster, and the other one the production cluster. For now, I'm just going to use production, but this is, let's say, recommended. So I'm just going to follow these conventions. Okay, so I've already put all these changes into my repository, as you saw. Now, the one thing that I have to do is actually patch my Argo Workflows installation, so my app installation, and I'm going to change the path from what was previously been 02 Argo Workflows now to 03 customization. So I can just do this with a JSON patch, which then means, so you can see here are my apps. Let's make it a bit bigger. And you can see there's my Argo CD app and there's my Argo Workflows app. And you can see that the path here at the moment is still Argo Workflows, 0 to Argo Workflows. And now I will change this to be 03 customization. And let's see what's going to happen. Again, this takes a few seconds because it's now checking this new directory, checking that everything is valid and can actually be merged, and also, the patch on top. Okay, and that did something. I can do an app list again, and you can see now that here it lists the 03 customization. Okay, so moving back to my cluster here, I now see that Argo Workflows is out of sync. And now I think the diff is a bit more instructive. So now I actually see that in the workflow controller config map, I have this patch that I added explicitly, and then I have these new roles created from the other resource that I just briefly flashed. So I can just sync. I can see exactly what will change. I say synchronize everything. And once this is done, that was quick, I can actually run my workflow again and see if that works. So it's following the same steps. Oh, but this time it succeeded. So that worked. And I mean, I had to apply a couple of changes, but I know exactly what I did, and I can reapply them at any time because I have everything under version control. So this is pretty cool. Now I can actually, for instance, look at the logs of this workflow, and I can see there are some logs. And okay, it says "Hello world." There's a whale saying this. So that worked. Okay. So now, one more thing that's interesting is actually and very relevant. I mean, I say we wanted to run a physics workflow. So far, we've done a hello world. We now have a workflow that consists of several steps, which usually all produce intermediate artifacts that are then consumed by the subsequent steps. And I will use CEFFS for this purpose. And as a last step, I actually want to copy the workflow result to EOS because that's synced with my CERN box, so I can actually look at the file once this is done. But in order to be able to do that, I will have to have a Kerberos token to copy files out. So that means I will have to get my key tab, my Kerberos key tab, as a secret somewhere into my cluster. And with Argo CD and SOPS and customized SOPS, we can actually do this and even put our secrets under version control without any risk. Okay, so I'm gonna skip this step here. So this is about creating a new Manila share size 1 GB. You should execute this on LX plus Cloud. I've done this already. And then once it's there, check that everything's there. And then there's an additional resource now in the base directory. It's again a different base directory, which is now called 04_secrets. And this is the CEFFS storage class. And that's basically directly following the Cloud docs as well. And you have to replace the OS share ID and the OS share access ID by the IDs that you get from the commands that are listed here. Okay, so I'm not going to do that in the interest of time, and all that I have to do on top then is look at the customization file and add an additional resource base CEFFS sc.yaml, and that's all I have to do in order to get the storage class in place for it to then be used by my workflow. And the nice thing is I don't even need to have any secrets there, but I will have to have secrets when I want the key tab to be stored. And now this part is actually largely following and even partly 100% copied from the GitOps Getting Started tutorial that I mentioned at the very beginning by Ricardo. It's linked here. So we're going to use OpenStack Barbican and SOPS in order to encrypt and decrypt secrets, and then be able to store them under version control. So now it's good if you actually clone this repository on LX plus Cloud or your fork of it and work directly in it, because we'll have to run a couple of commands that are only accessible within the CERN network. And it's probably best if you're on LX plus Cloud. So the SOPS client itself actually does not support Barbican, so we actually have to use a patched version. And I've created a patch. It's actually using a work by Ricardo, and just updating to the latest SOPS version. So I've taken that, updated it, put a Go release on top so that you can directly download these scripts. So I can execute them on LX plus Cloud. So actually I have to do one more thing. I have to source the RC file in order to be updated. And now I will just download this release, and I will run the other commands, and I will move this SOPS command to my home directory bin, which is in my path, so that I actually, when I execute SOPS, it's executing the one that I just copied there. Okay, so it's important that the environment that we execute the following commands and matches the one of your Kubernetes cluster where Argo CD is deployed. Okay, there was a note that you need to export an OS token if you want to do anything here, but I'm not gonna. I found that I don't need it if I set up things with sourcing the OpenRC file like this. Okay, so now this is again directly following what Ricardo had written. So I actually do not need to repeat this. So the idea is that you create a random key, then you store this key and give it a name. So in this case, it's called GitOps Argo CD, and then you define a secret href, which is this value. So I've done these first two commands already. So if I now run this command, let's see if that works. Okay, so I actually have now my secret URL, but it's not secret. I mean, it doesn't. I don't have to keep it secret because you won't be able to talk to it without my certificates. Okay, now the next thing we want to do is actually create a key tab. Okay, for that, using the KT util, and then inside the KT util, we would execute these commands, and that would then create a .key tab file. I think I already have this here. No, I don't. Okay, so I could run these commands, but I actually have the key tab already in place. So I'm also going to skip this and typing my password a lot of times. But in order to check if this works, you can actually then also run this command and klist, and you can see that I just updated my key tab. So that works. Okay, now we need to get this key tab into a secret. So what you have to do is cat the key tab, decode it, encode it with base64, and the same with your username. So here it's my username at capital CERN.ch, and then you create a file called Kerberos key tab secret, and then you fill it with the content using the output above. So in here, you would put the output of the base64 command and also the output of the key tab. Okay, and it's important that you do not add this file under version control. Okay. Now, the next thing to be done is then actually create the encrypted secret that we can put under version control. And it's again, following what Ricardo has described already 3 months ago. So it's running the SOP command with the secret href, and then adding here an encrypted regular expression just to make sure that not the whole file is encrypted, but only the user and key tab fields and everything else is still human readable. And then it's this file that is piped out to the key tab secret enc. You can try that yourself if you like. So actually have it here. Okay, so I mean, I have my key tab file here, and I could now cat it, and then you would see the content of it. I'm not going to do it, so you cannot steal my secrets, but you have to trust me that this works. And in principle, I can also then decrypt this. And decrypting, you don't need to provide all these parameters, because if you look at the file itself, it's probably best if I do that in the browser. You can see that well, this is now encrypted. So I have it in here in 03. It's in the secrets. And here I call it .enc YAML. And you can see this is the file. So this is the stuff that is not changed. Here is now the encrypted part, the user and the key tab. And then it has these SOPS fields that tell it about this is the secret href that you have to use. This is when it has been created, sometime yesterday. And also the version and also the encrypted regex. So this won't have to be repeated. So decrypting is really straightforward. Okay, so now we've done that. Let me find where we are. We've now have a file that we can put under version control. You see I've done it already. And now there's one more thing that we have to do, which is we have to be able to decrypt the secret using Argo CD. Because so Argo CD also needs to know how to use KSOPs, and Argo CD is itself pretty unopinionated on which secrets should be used. Or no, you can also use Vault or anything else. And now we have to basically teach Argo CD that it should use Barbican and SOPS. Okay. And we do that by patching our Argo CD installation. So we actually have to add two strategic merge patches on top of the default installation that so far we have not changed. There's one patch file that allows customized alpha plugins to be enabled, because this KSOPS plugin is an alpha plugin, and then another one that defines a container here. So this is important, that knows how to decrypt Barbican secrets, and in addition mounts here at the very bottom the so-called cloud config, which contains the secrets in order to be able to communicate if you're inside the cluster with a Barbican server. Okay, and now I've done this already under version control. In the interest of time, all I'm going to do is I'm going to patch my Argo CD installation again. So I'm now going to point the Argo CD installation to the 04 secrets Argo CD directory. And once this is patch is completed, I'm going to sync the app. And I mean, as usual, I would already say, I could go here now. I will see that it's currently syncing, and you can see that if you saw the Argo CD config map was patched, and I can also see that my repo server now that has just been created will actually also reflect this KSOPS image that I just defined. So that is all working. Okay, so now we've patched our Argo CD installation. Now we have to add the encrypted secret to Argo Workflows. So that was an intermediate step. We're moving to Argo CD. Now we're back to Workflows. And in order to do that, we actually have to create a so-called generator. So that generates the secret from the encrypted file. That is done with a file that looks like this. So it points to the encrypted file here. And then in the customization file, we create a new section, generators, that then contains the Kerberos keytab secret generator. Okay, you can look at that in version control as well. Now I'm just going to point my. Now there's a bug there. Okay. Might not have synchronized yet. Okay, let's try again. And if that doesn't work, then maybe we have to skip this part. I think it may be the Argo CD server has not yet synced completely, so that it doesn't know yet. Okay, that worked. Good. I'm relieved. And now I need to sync this, and then we should be ready to go. And now what we have to do is run a physics workflow, and that's already now I'm getting to the very end of this tutorial and presentation. We can run a physics analysis workflow. I've put an example workflow in here, and I said at the end it should put a file into a directory which is on EOS, so on my CERN box home then, so to say. So I've got this empty directory here. Now I can also create a port forward for Argo CD. So let me quickly also run this forward so that I can see my workflow server, which on my local computer points to port 5000. Okay, you can actually see now, okay, it's a bit small. You can see there's the failed workflow, hello world workflow, and then the one that succeeded 15 minutes ago. And now all I want to do is to submit this workflow, which is also part of the repository. And I'm just going to do it directly from the repository. So I'm not going to download it. Okay, this is actually a kind of complex workflow. Just to give you an idea, it roughly looks like this. So I prepare a new directory in CephFS, and then I have different data in Monte Carlo simulation samples, actually based on Rihanna beyond standard model search demo. So but it's all pseudo data here. Then I scatter my jobs. This is all created dynamically. Then I gather them, doing map reduce at the end again. Then I'm adding the data and then simulation files again, and I'm going to perform a fit at the very end, and then I should get plots that, if everything works, look like this. Okay, you can see now that this workflow is already started. So we missed the part where the CephFS persistent volume claim was created, but that worked. And now it's downloading the pod, and this pod is the same. So everything else will be running in parallel. Okay, and you can see here's my workflow now, and it's at the very beginning. It's nice. I can actually see what's happening. It's initializing the pod. I can see which containers it's pulling. So it's pulling a container from Rihanna Hub here, and I can see, what is happening and what is the status. I can look at the logs. They're not interesting yet because there's nothing happening. And this will continue. So this workflow will run for like 2 or 3 minutes. Once the container is pulled, you can actually see now it's now at the next step. And again, I can observe directly what is happening. You don't have to watch it live. Before I finish, I just wanted to point out one more thing. Now, we've actually created all these Argo CD apps by hand. We could have done it in the UI as well. We did it via the command line, but usually you probably want to have more than one app installed into a cluster. So there's a way to declaratively define the apps that you want to have in your cluster, and that's referred to an app of apps scheme, which is, as I said, particularly useful for cluster bootstrapping. There are some links for anyone who's interested in that. And in principle, you would just define a YAML file like this, which reflects strongly what we've executed on the command line. So we define an application with a name. It needs to be in namespace Argo CD, because that's where we're running Argo. But then the destination namespace is here Argo, for instance. And this is all exactly what we run when we run Argo CD app create, and including all these parameters. There's just one more thing here. There's a finalizer, which is if we want the resources to be deleted, if we delete the app, which is the case for Argo Workflows, because that we don't really need. But for Argo CD, you probably would actually want to remove this line so that it doesn't exist. Okay, and then one would just, again, use the command line, but now create with one command, in principle, an infinite number of apps in parallel and sync them, and then everything should be running. And you can see this workflow running, but I think I'll stop here. If the plots show up in this directory, I'll let you know, but I'm now happy to take your questions, and thank you for your attention.
Awesome. Thank you very much, Clement. It's very interesting. I'm checking for any questions already. Anyone? We can enjoy the workflow running in the meantime.
Yeah, it's all a bit chaotic, this one, but okay. Yeah, go ahead.
Yeah, there was a comment from Benjamin in the Cloud Containers channel saying that he feels less lonely that someone else is using Argo CD. But actually, I think you're not the only ones. There's more people as well.
Yeah,
And
I mean,
if there are no questions from other people, I had a couple. You mentioned that you were using Customize. I'm using Customize also for one of the deployments we have. And I find it a bit complicated to track when you have dependencies on other components. Like if you control completely all the YAML, I see a big benefit. But when you have dependencies, say for example, you want to depend on the configuration for MySQL or from external components, at least in the app that I'm using, it's not that trivial to track these components. Do you have any experience with this?
Yeah, no, you're completely right. I mean, you basically trust that they won't change any default fields when they update, let's say, the remote manifest, and you might not even notice if they add a field, right? So that's let's say a bit challenging. So I mean, the best way of doing this would probably be to really fix a certain tag or even commit on the remote repository that is not under your control, and then you use, for instance, Argo CD to update from one to the other. Because when you look at the diff between the app, once you've pointed it to a later commit or so, you will see exactly what is changed.
And I don't know, Benjamin, do you have any experience on this as well? I know you're a heavy user of Argo CD. I don't know if he's listening. No. Can ask him after.
Okay. Well, the good thing is the workflow just completed. You can see it's right. The last step was copy to EOS. So that was happening here. And now I can see, maybe you can read it. It's just completed now. And if I check here, I have the plot that I wanted to have. Okay, that was just a side note.
Very cool. So actually, we started looking at Argo CD as well as a possibility in addition to Fox. It seems like if you use Helm, it's the big plus is on the visualization, like what you have now. I think that's a big plus. All the rest feels a bit similar, maybe.
Yes, definitely.
The CLI, the structure and stuff. So as long as you use Helm, these two choices seem pretty good. In any case, it was very useful. I'm seeing if there's any question from the people here. I don't see any. So I guess, well, thank you very much. This was super interesting. And of course, if people have questions, they can contact you directly, I guess, or just ask in the cloud containers. We're all there anyway. Yes,
definitely. Yeah. If anyone has any suggestions on how to improve this, I'm also happy to learn.
Yeah, we might. Yeah, it might be useful to publicize also this option with Argo CD in addition to Flux, and make sure that we all use the same integration underneath with SOPS and things.
Mm-hmm.
Very cool. So last chance. No one. Okay. So then thanks again, Clemens.
All right. Yeah. Thanks everyone.
Bye bye.
Bye bye.